grading homework. We have the evens from last night. Yeah, what goes into 18? 9 times 2. Square root of 9, square root of 2. Which one do we know? Yeah, we know 3. So 3 rad 2 with a plus or minus. That's how they got their final answer. Just a few of you guys. Well, it seems like you got stuck a lot earlier than the 18 part. Seems like you got stuck a lot earlier than the 18 part. Okay, where else did we get stuck in homework? Help me out. So you guys are staring at me blankly. But I think that might also be because it's kind of like warm and stuffy in here. Calculus kids were taking a test. They were thinking hard. I don't know. We need something to wake us up. What else do you guys want to see? Yeah, Andrew.
10, 11, and 13.
10, 11, and 13. Okay. So what I'm thinking is that you might have, because of how we got stuck over there, I'm thinking that you might not have had the steps down. So number 13 is a lot like number 14, but let's peek at 10 and 11 pretty fast, although they look kind of similar too, right? If I was to go ahead and go take a picture of, let's just do 10 and 11 all at once with 9 through 12. Let me go ahead and just put it in our notes too. That way we have it in a nice clean spot. Remember, switching the inputs and outputs is how we started homework, but then we were supposed to just be solving for x and finding the input when the output is y. 2 things to do. Oh, not y. I mean, the output is y, but they're telling us to plug in for that too. All right. Let's get those problems up here. So I'm not going to take a long time, Andrew, because I think you might have just not known what you were supposed to be doing. But check it. What if, in number 10, what if I asked you how you started? If you're supposed to be solving for x, what do you think would be the very first thing? Because you had this down a second ago. What do you think would be the very first thing? Yep, plus 3. Do you know what would go next after adding 3? Divide 2. So we're going to add 3, we're going to divide 2. Now what did I say? If this little guy is confusing you, what can you make f of x equal to? Ah, close. No. Y. You can make it the variable. It has to still be a variable. It's not a number. Not until we plug in at the very, very end, 2. So y is equal to 2x minus 3. Andrew, you said, let me do Dr. that. And others were helping around you. We're going to add the 3 and then divide the 2. So I have to do that in order. We're going to add 3 to both sides. Does that go okay? Then we're going to divide 2. Why are we doing that? Because adding 3 cancels that out, right? And then, don't we have to divide 2 to get rid of that 2? What we do to one side, we have to do to the other. See it? And that's what the answer key would have shown for this first step of homework. Uh-oh, I just circled that divided by 2 when it was supposed to just be a separate step. I don't want you to think that's an x squared because he's really not. There we go. And then, Andrew, what did they tell us to do once we found x by itself? Then, yeah, what does that mean? Just plug in y is 2. So plug it in, plug it in. I have 2 plus 3 all over 2, which is a nasty fraction, but it's okay. They don't mind fractions, and neither should I. There we go. Do you see what you're missing?
Yeah, I already plugged in. So when I got the plus 3, I already plugged in.
Oh, okay. So you just had it switched. You were putting the 2 in the input spot in the f of input instead of realizing they want it in the output spot. So we solve for x. There you go. I think that will help you on the rest of them too. Does that make sense?
Oh, yeah.
Okay. Is there any other place that we got stuck in homework, in the directions or in the problems? Okay, who can tell me one big idea, looking at the worksheet or looking at homework, what was one big idea that homework was trying to have you practice? Input, output. Who's the input? Who's the output? Input is normally the x, output is normally the y. Okay, so input, output. What's another big idea from homework last night it was trying to have you practice? Switching. There's this switching thing. And what's the big word in your worksheet from 10.4a, but it's going to show up in 10.4b? What's the big word that's meaning to switch? Inverse. Inverse. Good. So inverse is switching something. And when we have or when we need inverse relations, we switch the tables or we switch the points or we switch the, what are those called? They're charts. There's a special name for them. I just forget what that special name is. But yeah, we're switching inputs and outputs. And then someone said plugging in or solving, and that was the last one, the solving. But what was weird is that we weren't happy with it the way that it was. We weren't happy with it the way that it was. We had to rearrange, and then we plugged in. Can I show you guys where homework is starting tonight? I technically probably should start homework here in numbers 15 and 16 with reviewing or remembering how to draw a line. But to be honest, do you guys remember when you first learned how to draw lines? Like y equals mx plus b, rise over lines. Is that this year or last year? Yeah, now you might have seen it a little bit in pre-algebra, but lines were a huge deal with Miss Evelyn in Algebra 1A. We haven't done a lot of them this year, which is why I'm going to actually have you guys on your worksheet. You ready? I want you to go find the section on the worksheet that looks like these directions, that says to find the inverse, then graph the function. Can you guys find in your worksheet which ones? Which ones have these directions? Find the inverse, then graph. Which problems? Yeah, 1 through 5? Is it 1 through 3 and 4 and 5? Yeah, I think so. Okay, good. So 1 through 5 has these directions. Here's what I need you guys to do. Ready? I want you to go ahead and cross out the second sentence. I'm going to cross it off on the test. I'm going to cross it off in our practice test. We are not going to have to graph the function in its inverse. Now, it might be a good thing before we stop the year, end the year, to remember some stuff about lines for you guys going into like geometry. And I think we'll have time to do a few like, hey, you're going to geometry. Let's talk about what you really need from Algebra 1A and 1B. Ever stand you focus. But for right now and for this test, we're focusing on radicals, we're focusing on squares, and we're focusing on inverses. We don't need to focus on lines. That's going to be a little too much. So did you guys, in both directions, did you cross it out in 1 through 3 and 4 and 5? Yeah. Okay, so what do you think I also want you to do in homework tonight? Because homework starts in number 17. Yeah, don't do the graphing. Okay? Which, I mean, most of you are like, thank you, because I don't like graphing. But don't do the graphing, don't worry about the graphing. I'm going to pull up my snazzy calculator because I want to show you what they want you to realize about inverses. And that's going to be good, but I'm not going to make you do it by hand or do it on a test, okay? So before we start today, you guys have already crossed off knowing that we are not going to graph the function in its inverse. I'm pulling up my snazzy calculator because he can graph stuff like parabolas, like lines. Ooh, those are matrices. Like parabolas, like lines. So I'm going to go ahead and, can we graph, let's see. What's one that you guys did last night? We were just going over, did I already get rid of him? Andrew, you and I were doing number 10, right? Okay, I'm going to go ahead and graph number 10 real fast. Let's go back to this one. I'm going to graph number 10 real fast. Number 10 was 2x minus 3. Let's just really quickly get a picture of this line. Now, last year you would have talked about that plus 3, or it's 2x minus 3. That minus 3 being the y-intercept, and the slope is up 2 over 1, up 2 over 1. That was a last year skill that you guys hopefully kind of developed. We just haven't reviewed it yet. This is 2x minus 3. However, does anybody still have their homework out? Didn't you also get an inverse? Now, in this calculator, we can do a really snazzy fraction thing, which makes life a lot easier. I have to remember what was in there. Does anybody still have it? Was it y plus 3 over 2? Yeah. The inverse? Number 10. I think Levi just found it, Anna just found it. It was y plus 3 over 2. Now here's the really sad thing. In my calculator, I'm not allowed to type a y in this because the y is always on this side. Like there's even a y equals button. I'm only allowed to have y equals, so it's going to look really funny because in homework last night, when you solved for x, this was a y, and it was like, okay, whatever, I don't know. But in normal math or in higher math, we actually aren't allowed to keep that y in there, so we've changed the notation, which is really confusing because that's an x and that's an x. We'll talk about that a little bit today. But I want you guys to look and see, can you figure out the relationship between these two graphs? Are they the same thing?
No.
No. Do they have the same y-intercept?
No.
No. Do they have the same slope?
Yes.
If you were climbing those hills, they would feel the exact same?
No.
No, right? That would be way easier than that one, true? Okay, so different slopes, different rise over runs, different intercepts. Well, what's the same? I don't get it. What's the relationship? They both have a meeting point. That's good. Called an intersection point. But also, do you guys see that they have a symmetry, like a butterfly has symmetry? What would happen if I folded this graph and folded this graph? What would happen if I folded across this diagonal line? Can you guys see it? Yeah, they would become one. They would be like the exact same thing. They would come together. If I was to draw, well, wait a minute. Maybe this was just a special one. Hold on. Maybe this was just a special one. Maybe not all inverses work this way. So let me show you another one. What if I was, I'm going to keep that line right there. Let's see if it'll let me keep it there. This is a way harder inverse. Oh, no, you guys did one of these last night in homework. Number 14 was that really weird one with a square, right, guys? Number 14, does anybody have that right there in their paper? I can get it with one. Number 14 was the weird squared one that you guys didn't like. But a lot of you didn't get that 18 that we had to do the extra work on over here. Let's see what happens when we put something that's even harder in here. So what if I put in, I forgot what it was. Was it 1/2 x squared? Okay. I'm going to be a little lazy. I'm going to put in 0.5. It's a little easier to type in. X squared minus? What was the next one? Number 14.
No,
Minus 7, thanks. So 1/2 x squared minus 7, there he is. And then when we went ahead and, this is a little bit tricky in a calculator, and you have to actually do it twice. You have to do a positive square root and a negative square root. The positive square root is going to be, let's see, it was y plus 7 times 2. So 2 times y plus 7. And then we had negative 2. I'm just curious if you guys can figure out the relationship, because actually this is part of your homework tonight, is knowing the relationship between graphs and their inverses. Okay, ready? Let's see. Does the same thing work? There's that guy. Can I fold it and they're going to meet? No? Check it. What happens if I fold right here? What happens? Oh, sometimes there's a zoom distortion. If you guys notice, this is actually a rectangular window instead of a square window, which makes it a little bit harder to see. Let's try now. Let's see if this makes a little bit more sense. Oh, but now my line's a little bit off. Let me redraw my line because I changed my window. How about now? Now could I fold it? Yeah, it was a little distorted because it was a little squished because of the rectangle. So if I change my units to be equally spaced, now I could fold and I could fold. It's kind of like a little sideways heart. These ones would match, these ones would match, those ones would match. It's a way harder graph, but it's the exact same pattern. So there's actually this really cool graph pattern that you guys would see if I had you do this part in homework where it was like, hey, graph the function and its inverse. But once again, I don't think we need to be graphing lines right now, especially when we have a test on Friday. Let's focus on the radicals, let's focus on the square roots, and let's focus on the inverse, the idea of switching and not worry about graphing. So here we are in our worksheet. You guys have crossed off that whole graphing thing. We're not doing, I'm going to cross it off in my notes too. We're not doing that part, even though it's cool and all. We don't need to focus on that right now. So here we go. You guys had this in your notes, right? The steps 1, 2, 3? All right. Help out those people around you. Remind them we have a test on Friday. Remind them that we care about their grades and we want them to pay attention. And here we are in the last topic of Chapter 10, Section 4, Inverses. I need you guys to box inverse and box undo. You know what? I'm going to do it in the highlighter. Box inverse and box undo. Box inverse and box undo. Yesterday we boxed the word inverse and I wanted you to get the idea of switching down. I also want you to get the idea of undoing down. But can you guys also come down and solve, box. We have 3 S's. We have set, we have switch, and we have solve. Set, switch, solve. The 3 S's of inverses, at least tonight's homework. All right, inverse, undo, switch. If you have those 3 words and you know what they mean, man, you're going to be awesome tonight. Caleb, do we box them all? Inverse, undo, and switch. It's written in your paper, 10.4b, the second side, which is what we're going over today. All right, here we go. Ready? Step 1 says, whenever you're given a problem that says, find the inverse. Do you guys see this right next to the steps?
Yeah.
Yours is right next to you, mine's below for sake of seeing it simpler. The very first step is we are going to set y in for f of x. We're going to set y in for f of x. But then, once that y is in there, now it's time for us to switch. If you guys just noticed in my nifty-gifty graphing calculator, I cannot let a y be in that equation. So even though last night it was okay for y's to be in the equation, for function notation it's actually not allowed. So what we're going to do is we're actually going to switch ourselves the x and the y, which seems really weird. But it's because of this whole proper notation weirdness. So last night there were y's in the equation that you were plugging in for, but that just got kind of confusing, and some of you felt that when you were not sure where to put the x, or the 2, I should say, that you were supposed to be plugging in. So we're going to set the y for the f of x. We're going to switch the x and y. We did the set, we did the switch. What's left?
Solve for y.
Solve for y, which is what you were feeling last night, in that we have to, ready? Undo what's ever been done to the variable. How do you undo multiplication?
Divide.
Yeah! So it's as easy as, we'll divide by that 6, and then, okay, well wait a minute, what do you have left? The y of the inverse is equal to x over 6. If you actually want to be super snazzy and get ready for Algebra 2, we wouldn't write it like this. I may even do it in a different color so you guys don't get all stressed out by it. If you want to get ready for Algebra 2, we actually wouldn't write it like this. We would actually write it to distinguish it from the beginning. We would go back and we would say, hey, you were f, cool. You're f's inverse. And there's this snazzy -1 notation that's kind of the idea of inverse, the idea of undoing. And so we would write it as f inverse of x is that x over 6. I'm going to rewrite it a little bit better because it got a little too big. That's only if you want to think ahead to Algebra 2, which I know you're like, that's so far away, but technically it's the next math class in this series. Just geometry is kind of like a timeout, let's get super practical, still kind of practice our algebra skills, but go into this other field of math for a while before coming back to Algebra 2. But anyway, here's a really snazzy way of writing it, but this is more like an Algebra 2, and you're going to write it up here so you guys don't get all stressed out. Your book's probably not going to write it like that. But f inverse of x. And it would say, hey, you have a y? Awesome. Well, he has a y also. So they're allowed to be different. That's what I want you guys to see. They're allowed to be different because you can have x's and y's of all sorts of different things. And in this one that I just showed you, the graph, remember, this guy, the red one, he has y's and x's, but the blue one has y's and x's too. Remember, a lot of different equations use y and x. Well, let's see if we can do the set, switch, solve on another one. So letter B. You guys, help me out. What's the first step?
Change it to y.
Change the f of x to his y. Just makes it easier. Like, okay, yeah, where y's are. All right, that's the set. Now what? Switch. What are we switching? Oh, someone help me out. We're switching? Andrew, what are we switching? What thing? It's okay, just read it.
Switch.
Who?
X and Y.
Okay, so we're taking the x, we're taking the y, and we're switching their locations, yeah?
Exactly.
So x's location is going to be over here, y's location is going to be over here. Have I done any math? No.
No.
I literally just... Yep. So I plugged y in for f of x. I switched x for y. Not quite it, but it's almost it. Everest, what's the last step?
Solve for y.
Solve for y. Now, how do I solve for y? I'm going to undo what's been done. I'm going to undo what's been done. But you guys have been trained so well, hopefully you know how to undo a plus 5. How do you do it? Minus 5. Careful, some of you get really confused right about now. Can I combine x and minus 5?
No.
Nope, so I just write it. But wait, is y by itself? Nope. What's in front? It's slight. It's sneaky. Yeah, the negative. We have 2 options. Actually, we have 3 options. Let's see which one your guys' brains say to do. You're going to multiply, you're going to divide, or you're going to add it to the other side?
Divide.
Okay, so if we divide by a -1, here's where I get really scared. any level of math. Even my calculus kids, if they're doing a super hard problem, if they're dividing by a negative, I'm like, guys, please don't kill a seal. Wait, kill a seal? Which one's that? That's if you have parentheses and a minus in front. What does the minus need to do?
Go in the parentheses.
Yeah, distribute to how many of them? Both. This was a mistake, right? It shouldn't be plus 2x. What should this be?
Minus.
Yeah, that's why the seal's that. So, what does that mean over here when we're dividing instead of multiplying? You guys thought straws were bad. Anyway, it's going to be a plus 5 and what kind of x? A negative x. Good, Caleb. It even works for dividing, not just multiplying, because dividing is multiplication of a reciprocal. So actually, whenever we divide a whole group of terms, we have to distribute that division the same way we distribute multiplication. Anyway, that's why I'm really scared, because a lot of people would put the negative here, but not switching the sign there. Once again, if you're getting ready for Algebra 2, you could write this in a super snazzy way and be like, ooh, so there was that whole other name for the guy who's the inverse. But I think in our homework, to be honest, they're just letting us write it with the new y and say, okay, it's somebody else's y, and I'll just box it. So in ours, it's okay to stop there. Getting ready for Algebra 2, though, you would say, hey, there's this snazzy name of the inverse of f. And here's what I want you guys to realize, without going all crazy and Algebra 2 free calculus on you. The cool thing about this guy and that guy is if I was to do what we call a composition of functions where one goes into the other, f of g of x, if you've ever heard of fog. I know, we're getting super crazy and super intense. Or if you ever see something like this where it's like a function in a function, if you ever plug them in to each other, whether the inverse goes in that guy or that guy goes in that guy, they completely undo each other. He's adding 5. Oh, that's weird. He's adding 5 and he's adding 5. He's subtracting 5 and he's subtracting 5. Hold on. What does this guy look like? Let's peek at his graph real quick. If we were to try to graph this guy, how did they end up being the same thing? Let me get rid of him. Let me get rid of him. Let me get rid of him. I thought they were supposed to fold over that snazzy line and all. If I have negative x plus 5, what does he look like? What's so special about? What's so special about him? Isn't he his own fold? You guys see it? If I was to graph the other guy, and if I was to graph the inverse, it ended up, I mean, did anybody notice it was super awkward, super weird, because they were the exact same thing? I don't get it. But check it. If you fold him, what happens? There are only a few very special functions that are their own inverse. Do you guys want to see one more? He's probably way beyond where we are right now, but let me show you one more guy. What if I give you 1 divided by x? Do you see how he's his own fold too? Now it's kind of hard to see because the pixels don't show you this keeps going on forever and ever. It just kind of quits and it poops out because it's like, nah, I can't show it to you. I can show it to you this way, but not that way. Andrew, you're distracted. But this guy folds over, so he actually is his own inverse too. So every now and then it's weird, but guys, it's super rare that the inverse is the exact same thing. I don't want you to take away from this like, oh, that always happens. No, look at this guy. He was way different. Now you guys have 1, 2, and 3, 4, and 5. I want you to do the best you can. I'm going to slowly come behind so you can check your answers. But I want you to, ready? Set the f of x to be y. Switch the x and y. Solve for y. Ready, set, go. Set the y for f of x. Switch the x and y. Solve for y. Meanwhile, let me see if I can get my computer to stop freaking out. Start with 1, 2, and 3. Do exactly what we did in the examples up above. Set f of x for y. Switch x and y. Solve for y. Okay, 1, 2, and 3. We're checking our worksheets tomorrow. 1, 2, and 3. We're checking our worksheets tomorrow. Follow the steps in the examples that we just did. And it's written on your paper too if you need a reminder. If you're afraid to make a mistake, I'm going to start myself in just a second. And if you guys notice, you can set that f of x equal to y a lot quicker than we were doing, can't you? Ooh, that saves some time. Andrew Everest, have you made all your f of x's y's? You can do it real fast. And if you've gotten 1, 2, and 3, try 4 and 5. I've set. Now it's time for me to switch. And then the point of inverses is that they undo. They undo everything. So now it's time for me to get in there and undo all of that math. The first one, the undoing, the getting y by itself, needs an addition and needs a division. Do you guys get them both? Do you guys get the addition and the division in the proper order?
Yes.
Addition, then division. Can anyone look at the second one and know what it means before we even start? Subtraction, good. And? Division, good, Andrew. The second one needs subtraction. I need to undo the addition. Am I dividing by 3 or negative 3? What did you guys already do if you got there before? Divide by the whole thing.
What do you mean x?
Oh, because I did my step 2. Look right up above, Jerry. Step 1, set y for f of x. Step 2, switch x and y. So I literally just switched the locations of those two variables. Now, just to warn you guys, they're actually going to write this a little differently in the book probably because of that negative. That divide by 3 is okay, but they're going to distribute that negative to probably have a negative x plus 1. So it looks a little bit nicer not to have a negative in a denominator. But if you wrote it this way, you're not wrong. I wouldn't mark it wrong on the test. You're not wrong, just they're going to write it differently in the back of the book. Yeah, they almost always don't like to leave negatives in the bottom. It's technically like not simplified. Hopefully most of you guys see that this one also needs an undoing by addition and then a division. Oh, but there's another negative in the denominator. So, does anybody know how they're going to write this answer? Careful. Did you get negative x minus 4? Careful. Distribute. Does that make sense? It's so tricky. It's so tricky. Yeah. Yeah. It just would look differently than the answer in the back of the book, so I just want you to understand their answer too. Now guys, we do have 3 and 4, or 4 and 5. To be honest, I'm not going to make you guys stress about this little greater than or equal to, less than or equal to. I'm not going to make you stress about that. That's a little bit intense. But I do want you to at least see that it's not really all that different. All that's different is these are harder ones, like the end of homework last night. These have squares in them. But otherwise, our process is the exact same thing, except all that's different is this time, I need to get rid of the squared, but I can't do that first. I'm going to have to undo any multiplication or division and then go tackle the squared. But guys, hopefully you remember, how do we tackle squares? And then maybe as you saw last night, that would, or at least even today, that gets us with 2 different answers, the positive and the negative, which the book is actually going to keep going because we know the square root of 4, even though we don't know the square root of x. I'm not going to make you guys worry about number 5 for right now, because as long as you have one example with a squared, I think you should be okay in homework. Maybe we'll use number 5 as like a warm-up tomorrow to see how you did. But we need a couple different things that are weird. We need to bring in those square roots, but only when the squared is alone. We need to bring in our plus or minus because we have 2 different answers. And then we look and see, is there anything that we can simplify? Now guys, here's the sad thing. You're like, 6 and 7, we won't be able to finish homework. But here's what I want you guys to see. There's this thing called the horizontal line test. And all you need to ask yourself is, does the graph fit a horizontal line more than once. You guys learned, hopefully, a long time ago, the vertical line test, how you knew whether or not things were functions. All I need you to think about for these guys is draw an arbitrary horizontal line and ask yourself, does it hit more than once? If it does, it fails. If it doesn't, it passes. So question, hold on 1 second as you get ready to leave class. Does this one hit more than once?
No.
Yeah.
Yeah, it does. It hits twice, right? So this one fails. Does this one hit more than once? No, it only hits once. This one passes. That's it. It's as easy as that. Just ask yourself, does it hit a horizontal line more than once? If so, it's a no-go. If it doesn't, it passes. Bye, guys. Take a picture of the backboard or homework is up here. Super fun. Bye, guys. Remember, there's a test on Friday. If you want to do well on that test, please come during period 7 or after school.
I never got the worksheet.
Oh, were you gone yesterday?